Hello students, today's lesson is on forming equations, and our learning objective is to be able to form and then solve equations, okay? And along the left side there's some real life links and some keywords which we've been using for the last week or so. Obviously dealing with the basics of algebra. These are words that I would ideally like you to be very comfortable using and to at least understand what each of them mean and what their purpose is. If you look along the right side, there's a big question which we won't be going through today's lesson, but I would like you ideally to try and have a go at it if you can. Once you've done all the maths watch and you've watched the video, you've answered the main activity, you've taken a picture of it and uploaded it. If you feel like you're comfortable, I want you to try that big question, okay? Now, before we go into the actual lesson, forming equations, I feel like by now we should know what an equation is, but the word form, to form or forming, is it means to bring together, to create. So if I was to form a football club, I've created that football club, I've made it, okay? Just an example of what it means. Now, imagine here I've given you just this simple statement: form more than a number. Now, what number? We don't know. The question hasn't given it. So we will call that number, in this case, we're going to call it n. Okay, and because it's 4 more than a number, we are adding 4. If you said 4 less than a number, then of course you would be subtracting 4. So our number is n plus 4. That is the same as 4 more than a number. Okay, and now this letter, as we've said in the past, it doesn't have to be n. It could be any letter or symbol. We usually use x. I think in the last lesson with solving equations we were using it as x. I've deliberately put n to show you it could be any letter, okay? We could even use symbols, but we're not going to do that though. I want us to stick to letters, ideally n or x. It could be any letter if you really wanted it to be. Now let's have a look at, for example, here, 4 lots of a number. So, for example, if our number was 2, what would 4 lots of 2 be? That would be 8. But because we don't know what the number is, it's not telling us that it's 2, we have to leave it as a letter. So again, we'll use n. And if I have 4 lots of n, it is going to be 4 times n, which we should all know equals 4n. Okay, so 4n is the exact same thing as 4 lots of a number. It has the same. What about this one here? A number divided by 5. A number divided by 5. So we're going to call our number n again. And n divided by 5, we could write n divided by 5 or n over... This is the algebraic way correctly to put it is n over 5. It's the same thing as saying a number divided by 5. Okay. Now, I'm going to give you a worded example here. So Sam's brother Tom is 3 years older than Sam. Their dad Will is 4 times as old as Sam. Find and simplify an expression for the sum of their ages. So first things first, we don't know how old any of them are. We just know that Tom is 3 years older than Sam, and their dad Will is 4 times as old as Sam. Okay, that's the only information we've been given. Now, the second part is asking us to find and simplify an expression for the sum of their ages. Okay, but first of all, we need to know what their ages are in algebraically. So if Tom is 3 years older than Sam, so Sam must be the original number. So we're going to call Sam n. Okay, we'll call Sam n because he started off talking about Sam. And on top of that, it's telling us that someone is 3 years older. So we can just add on 3 for Tom, and Tom will be n plus 3. Okay, now what would Will be? What would their dad Will be? I want you guys to think about it. I'll give you guys a few seconds before I put the answer up. I know it's my example, but I do want you guys to think about what you think it will be. Okay, so it's told us that dad is 4 times as old as Sam. So if Sam is n, then dad must be 4n. Okay? And now we can go on to the second part of the question where it's saying find and simplify an expression for the sum of their ages. Now the sum of their ages means the total of their ages. So in this case, we are just going to collect the like terms. And if we do that, we've got dad is 4n, Tom is n, and Sam is n. So if we bring all the n's together, that will be 6n. And then we just have a plus 3 on the end. So the final answer would be 6n plus 3. Okay? Now, I want you to have a go at these 3 examples. I want you to So treat them all separately. So the first one, there are n pupils in the row. 2 more join the row. How many pupils are now in the row? Now the second one is actually linked to the first one. So a second row of pupils is added. There are now 2 rows of pupils. So what would we call 2 rows of pupils? And then finally, there are 3 rows here. Each row has n pupils. 5 pupils are added. What is the total number of pupils? So treat them separately and try them now. I'll give you guys a few seconds. Pause the video, have a go, and we'll come back together shortly. Okay, so we should have done those 3. The first one, nice and easy. If 2 more people have joined the row, it's going to be n plus 2. Okay, so the row is n. We had 2 people join. It's going to be n, however many people are in n, plus 2 more people. Okay, the second one is going to be, there's 2 rows. That would be 2n. And then finally, the last one, there are 3 rows here, so I'm sure you guys would have guessed it. There's definitely a 3n in there. And now we've added 5 pupils, so that has to be 3n plus 5. Okay? Now, again, we're going to try these examples. These are worded examples, and they are all linked together. There's 5 questions here, and then a challenge question, which I want you guys to try. So, Farmer Harriet has a vegetable farm. She plants K carrots. She plants so we know that carrots equals K. Okay, that's very important. You understand that? Carrots equals K. So we don't know how many carrots she's planted. We're just gonna call it K. So she plants the same number of leeks as carrots. So how many leeks has she planted? The answer will be K, because it's the same number as the carrots, and we know the carrots is K. Now she plants 15 more potatoes than carrots. So how many potatoes has she planted? So I want you guys to, I'm going to give you guys, I want you guys to pause the video for a couple of minutes, try the rest of the activity, and then we'll come together for the answers and move on. So pause the video now, have a go. Okay, now number 2, the answer we should have got would have been K plus 15, because it's 15 more potatoes. Okay, number 3, she plants 3 times as many courgettes as carrots. She plants 3K, because it's 3 times as much as the carrots, and as we discussed, the carrots is K. She plants 8 fewer pumpkins than carrots, so fewer means less, so it'd be K minus 8. And number 5 would be K divided by 2, or K over 2. Okay, I did explain to you guys algebraically we should put K over 2. It's just with the way it is here, we aren't able to do that, but it's still correct. Okay, it's still the same answer. Now, the challenge question was, how many vegetables did she plant altogether? Now, similar to the last example with Sam, Tom, and their dad, where we had to bring everything together, we must do the same here. Except for number 5, the answer is half K, basically 0.5K. Okay, so if you bring all our K's together, how many K's did we have? And then we bring our numbers together when we collect those terms. And what number did we end up with? Our final answer should have been 6.5 or 6.5K plus 7. Well done if you got that correct. Moving on to the main chunk of the lesson. I feel like we should be comfortable in terms of writing a number and doing some, basically turning it into an equation, but now we need to also solve it. So I'll give you an example here. I think of a number y, so the question's told us it's called y. I double it and then add 4. I get 40. What number did I think of? So first things first, we need to create our equation. If we had y and we doubled it, that would become 2y. And then you added 4. So we would have got 2y plus 4, and then it said I get 40, meaning it equals 40. Okay, so we've made an equation here. And now, as with the last lesson where we were solving equations, all we do is work backwards to solve it, and we do that by starting off by getting rid of the plus 4. Okay, so if we get rid of the 4, we're left with 2y equals 36, and now we just divide it by how many y's there are. So we're dividing it by 2, and y would equal 18. Okay, and we can check it through the sentence. I think of a number y, so now we've basically said that number that you were thinking of was 18. So let's say, okay, I think of 18, I double 18, which is 36, and then I add 4 and I get 40. So it's correct. Okay, we've checked it, it's correct. I want you guys to have a go at this question here. So I want you to pause the video now, have a go, and we'll come back together. Okay, so we should have answered this question now. First of all, we created the equation, which was 2y minus 3 equals 27. And then obviously we're doing the inverse of that. 2y equals 30, and then y equals 15. Okay, our final answer should have been 15. This is the main part of the lesson, the main activity. I want you guys to try each of these 5 questions. You're going to write the questions out, create the equation below, and then obviously solve it by working backwards. So you're going to do that for each of these 5 questions. Take a picture of that, upload it to your class charts, and your teachers will look through that and give you the feedback if they need to. Any questions at all, anything you're confused with or not sure about, you can message through class charts or via MathsWatch, and your teacher will be able to assist you there. Okay. That's all for today's lesson. Thank you for watching the video, and hopefully you understood this lesson and were comfortable with it. Thank you. Bye bye.